everybody. For today's homework, I've chosen from section 6.2, question number 11, not 12 like I wrote in my paper. So it's 11. And they are asking us to find the volume of the solid generated by the revolving the region in the first quadrant, bounded by the curve x equals 3y minus 3y cubed, and the y-axis about the given axis. So they first are asking us for the volume of the solid form where we are turning it around x. So what I did first, again, I really like to see what I'm working on. I actually did my little graph over here to figure out what I was doing, and based on what they're telling me in the problem, they're also telling me that I'm working on the first quadrant. So given that, and they're telling me that it's revolving around x, then I knew I needed to find everything in values of y. So to determine first my limits, what I did is I took this equation and I said, since x is going to be 0, like over here, then what's going to be the value of y? And then the solution was telling me that y can be either minus or plus 1. Since I'm staying on the first quadrant, I'm just keeping the plus 1, as you can see over here. So the next thing I did, as they are asking us at this point to use the shell method, is I find my shell radius and my shell height. So as you can see, I have over here will be the radius, and then the height is going to be this body over here, and that's pretty much going to be this equation. So I plug those values on the formula that we have. So it says it's 2p, and then that's going to go between 0 and 1 based on the information that I got from here. And then my shell radius is going to be y, and then my height radius, it's going to be 3y minus 3y cubed. So that's what I have here. And this is what I started resolving. So pretty much I just start multiplying the y for the 3y minus 3y cubed, and then after that I took the antiderivative over here, and we still know that we're going between 0 and 1. So if we do the f of 0, we know that's going to be 0, and then I solve the f of 1, so it was 2 pi, and then y cubed of 1 is going to be 1 minus 3 divided by 5, y elevated 5, that's also going to be 1. So I just use a common denominator 5, and I multiply 1 for 5, subtract 5 minus 3, that was 2 divided by 5, times 2 pi, that was 4 pi divided by 5. So that was the first answer. So then after that, they're asking us to again find the volume of the solid, but when everything moved to y equals 1. So based on the previous picture, now we know 1 is actually on the first quadrant, and then our new shell radius it cannot be the one that we used before, so it's actually going to be 1 minus that one. So that's why I plug this over here, and then multiply it again. The height is going to be the same, the limits are going to be the same. So what I did from here is I multiply everything over here, and then on this case I decided, since everybody had 3's, I decided to take that 3 out. So that's why I have this 6 pi here. And then what I did is I took the antiderivative of all of this, and that left me with this over here. And then we still know that that goes between 0 and 1. So for f of 0, that actually equals 0. So then I did it for 1. And this is what I got. So what I did again, I used a common denominator, 60 in this case, and resolve accordingly to that. I ended up having 7 divided by 60, and then I know I still had my 6 pi, so I did 6, 6, and that was 10, and that's what the result for the second question was, 7 pi divided by 10. Hope that was clear, and let me know if you guys have any questions. Thank you.